This video is about uniform acceleration. In physics we use the word uniform to mean constant. So it means as time goes by, the acceleration is the same second by second by second. You've already come across the equation that acceleration equals the change of speed divided by the time that change took. Now you're also expected to use a second equation, which is this one here, that the final velocity squared, take away the starting velocity squared, is 2 times the acceleration times the distance. And this is quite often abbreviated to v squared minus u squared equals 2as. Now you're not expected to remember this equation, but you are expected to be able to use it. And in using this equation, questions will quite often ask you to do things requiring you to rearrange the equation. The syllabus here also says that near the Earth's surface, any object falling freely under gravity has an acceleration of about 9.8 meters per second squared. Now, because this is stated in the syllabus, it is advisable for you to remember this. However, in most questions, they give you the acceleration due to gravity. It is very easy here to get confused with the symbols and the units used. In physics, the unit for distance is the meter, but the symbol used in equations is a lowercase s. This is an abbreviation for the Latin spartium, which is the Latin word for the space between 2 points. We then have the unit for time is seconds, which is also abbreviated to an S. So you just need to make sure you have that clear in your mind, the difference between a symbol used in an equation, v squared minus u squared equals 2as, and the symbol used for a unit. Here is a typical question requiring you to use this equation. So we have a ball dropped from the top of a building. The velocity of the ball when it's 2.25 meters from the ground is 6 meters per second. Calculate the velocity of the ball when it reaches the ground. Now I've illustrated this on a diagram here, which is a useful thing to do if you have a question like this. Just helps you focus everything, see the situation. So I've shown the ball there going 6 meters per second. I've shown the acceleration due to gravity 9.8 and the height above the ground is 2.25 meters. Again, it's good practice to write down what you know. So I've written down initial velocity equals 6 meters per second, acceleration 9.8 meters per second squared, and the distance 2.25 meters. When you do that, it's advisable to write down the units, and then you can spot very quickly whether you have to change any units to suit the equation. As you can see in this one, distances are all in meters, times are all in seconds, and therefore we don't have to change anything. Then applying the equation, v squared minus u squared equals 2as, we put the numbers in, and then we can work it through. On the fourth line of the working there, you can see that we've rearranged the equation, taken the 36 across to the other side by adding 36 to both sides of the equation. You end up having to square root your total there of 80.1, and that should give you an answer of around 8.9 meters per second. In the last example, you were asked to work out a speed. This is an example where you're having to work out the distance travelled. So we've got here some data on the stealth ride at Thorpe Park. Accelerates you from 0 to 36 meters per second in 1.9 seconds, and we're being asked what is its vertical height. Now, if you're confident, you can stop the video here for a moment and see if you can work it out. Now, if you've had a go, you've probably realised that this is actually a two-step calculation where you have to work out something in order to work out something else. So your first step is to work out the acceleration, and then once you have that, you work out the height. Now, if you haven't had a go so far, that may be enough to help you get going on the question. So pause the video, have a go at it now, see if you can work out the acceleration and then use that to work out the height. So here we're using the equation acceleration equals change of speed divided by time. This is one of the equations you have to remember, so you won't be given that on the data sheet. Again, I've written down what I know. The change of speed is 36 meters per second. The time is 1.9 seconds. So I simply divide those two, 36 divided by 1.9, and it gives me an acceleration of 19 meters per second squared. We then insert our acceleration, 19 meters per second squared, into the second equation. So again, I write down what I know. So I know my initial velocity is 0, my final velocity is 36 meters per second, and my acceleration 19 meters per second squared. Second equation, this is the one you're given in the data sheet, so v squared minus u squared equals 2as. Insert the numbers, rearrange, and you should end up with a height of 34 meters. Now, the actual maximum height for the ride is 62.5 meters, and that is different from this. It's different because we've assumed uniform acceleration. Well, actually we haven't got uniform acceleration here because of the uneven shape of the track. The syllabus states then that students should be able to estimate the magnitude of everyday accelerations. You know that acceleration depends on the change of velocity and the time taken for that change of velocity. So if you're estimating the magnitude of some accelerations, you need to estimate the velocity change and estimate the time taken for that change. Now, you are expected to know some standard velocities, and each one doubled the one before. So you've got walking 1.5 meters per second, running 3 meters per second, and cycling 6 meters per second. Driving, you could choose anywhere between 15 and 30 meters per second. 30 meters per second is about 70 miles an hour. 15 meters per second is just over 30 miles an hour. In this situation, we have to estimate the time taken for the walking speed to go to 0, so we could guess half a second. Speed of walking is 1.5 meters per second. Acceleration is the change of velocity divided by the time taken. That's 1.5 divided by 0.5, which gives you an acceleration of minus 3 meters per second squared. It's minus 3 meters per second squared because we are slowing down. So in this question, again, you can see there are no numbers given you at all. So you have to come up with estimates for the numbers that you need. A car is travelling along a road, goes out of control, collides with a tree and comes to a stop. Estimate the deceleration of the car. So we have to come up with a sensible speed for the car, and then we have to estimate how long it would take the car to stop. In questions like this, you need to use that special squiggly line there to mean approximately equal to. So again, let's lay out what numbers we're going to use. The speed of the car I'm going to take at 20 meters per second. You could choose 15, 20, 25, 30, anywhere in that range. The time to decelerate, well, I've estimated about a second. Cars crumple at the front when they collide, and so that the time taken is probably somewhere around that. And so the acceleration is the change of velocity divided by the time. So that's 20 divided by 1, which gives me an acceleration of somewhere around 20 meters per second squared.